Off how to do the scaling. Now, after our last period, let me just say this up front. Ms. McShannon and I understand there are a lot of different ways to do these problems. We are familiar with all of them. We are choosing the way that is going to be the easiest for you to be successful with if you will do it every time. But it does require you to actually practice it. So please try to do what we're telling you to do. Pay attention because it's very important that you set the problems up properly. But if you do, these become easy. So our first one on page 308, we're going to use ratio tables, just like we've done with equivalent ratios, because this is a strategy you can use to convert units. So you're going to complete the ratio table by converting between pounds and ounces. There's our task. And then you can talk about the strategies you used. That's going to be showing your work. So do arrows, show us how you're going from one entry to the other. You should have arrows going to all three of the blank spots, telling us how you got there. Second one, we're also completing the ratio table by converting between milliliters and liters. So there's our task. Which strategies? Again, show your work. This one's a little odd. They have this blank one. So you can do whatever you want in there. Just make sure it's equivalent to the other ratios. Make sense? So you got 2 problems to do. There's only about 8 total spaces, so we'll give you guys like 4 minutes. You can work together as a table. Go ahead and get started. One of the big keys on this is showing how you got from one to the other. You can use either additive or multiplicative reasoning as long as you showed it. So I'm just going to show you the way I would look at it. That doesn't mean this is the only correct way. However, regardless of how you do it, your answers should be the same for the box. So for me, when I see going 1 to 2, I just say, oh, that's times 2. So 16 times 2 gives me 32. I personally would then say, wait, 1 1/4? Well, I have 1 1/4. So I'm going to do additive reasoning, 1 plus 1/4, meaning I'm going to add these pieces, 16 and 4, to get 20. Then for me, at 1/2, I say, oh, wait, that's just another times 2. So I do 4 times 2, and I get 8. So your reasoning could be additive or multiplicative from any of those. You just have to show it. Does everybody understand that? So if I have just a bunch of boxes filled in with no work shown, am I getting full credit? Legend? Brock? Am I getting full credit? No, I'm not. Same thing happens on the second one. Now here's the nice thing. When I'm using the metric system, all I'm doing, guys, is moving decimals. So it's what makes the system so nice. Going 100 to 1,000 times 10. Meaning all I'm doing is moving my decimal once to the right. It's getting bigger. That's 1. This one they left wide open for me. So I'm just going to do, we don't have a 10 up there, so I'll divide by 10. To make it a 10, divide by 10 gives me 100. That's a 0, sorry. On this one, 1,000ths. So this one, I'm going to go times 10 because it's getting bigger. This one, I multiply by 10, gives me 10. The only one that's at all difficult would be this one, but it's really not that hard because they gave me a 1. So I'm just doing this times 575. So I do 1,000th times 575 to give me 575 thousandths. Again, that is not the only way to do it. That is just the way I would look at it. I always try to make the numbers as easy as I can. However you do it is fine. Okay, let's go ahead and pull out our marking pens real quick. Our highlighters. What? Not right now. You can grab a colored pencil off the side if you need it. So here's what we're going to do, guys. Most conversions that require moving between U.S. customary and metric are approximations. We're not going to give you exact ones. In other words, you're going to see the little squiggly equal sign a lot. In general, you'll use conversion rates rounded to the nearest hundredth in our calculations. In the ratio conversions that they give you, they will be to the nearest hundredth. So they are approximations. You're not going to get exact, but it gets you close enough for the work that we're going to be doing. Okay? What we're going to do is proportions. This is the way that Ms. McShannon and I prefer these set up. So get used to this. You're going to use the conversion rate based on the given measurement. Then we're going to scale up or down to convert one unit to another. So go ahead and mark your text on these, especially this note here, because on the side, the did you know is probably the more important of the two, knowing that we're just using approximations. Go ahead and go to the next page. So we are now on 309. Here is what it is going to look like as we set these up. You can scale up or down a ratio to convert between units. You can scale up to determine how many kilograms are in 2.5 pounds. Because you want to determine the number of kilograms for a specific number of pounds, use a conversion rate of 1 pound is about 4,500 kilograms, or, and this, guys, is what we're going to be doing all day, so get used to this. We're going to turn our conversion factors into a fraction. All the conversion rates will be as a fraction. They've given us the approximations, so I would probably dog ear or highlight all of these. These are the ones that we're going to be using all day today. One key on these, you notice all of your conversions start with the number 1, right? That is the one that we are wanting to convert from. So we're going to set these up based on we're converting from, not what we're converting to. Now, why does the worked example use a conversion rate of 1 pound over 4,500 kilograms rather than the rate of 2 2/10 pounds over 1 kilogram? Why do you think we did the 1 pound in order to do our conversion? What would have happened if I had 2 2/10 pounds up here to 1 kilogram? What do you think? Here, I'll give you a hint. Would you rather go from 1 to 2 5/10 or from 2 2/10 to 2 5/10? Serena? You'd rather do 2 2/10 to 2 5/10? Really? What do you multiply 2 2/10 by to get 2 5/10? What do I multiply 1 by to get 2 5/10? See why we do the 1? So, whatever I'm converting from is the one that I want as a 1. Okay? So there is our key. Go ahead and write that down. What I'm converting from should be the 1. So that's the unit of what I want, is what I'm converting from. Why? Because it's going to make the conversion easier. Because I know whatever's on top is what I'm multiplying by. It tells me my arrow really quickly. Okay, on our second one, we're going to set up a proportion and then scale up or down to answer each question. The school cafeteria has 8 huge cans of tomato sauce for making pizza. Each can contains 2 gallons of sauce. Is there more or less than 50 liters of sauce in these 8 cans? So there's our question. So don't let this one confuse you. Am I converting cans or am I converting gallons? Gallons. What am I converting the gallons to? Liters. So that's my conversion, and then I will need to multiply it by 8 to see if it's more or less, okay? So convert the gallons to liters, multiply it by 8, see if you get more or less than 50. Use this type of setup, okay? And your conversion factors are right up here on the right. We'll give you guys about 2 minutes to do this one. Go ahead and get started.
Yes. Okay, the school cafeteria has 8 huge cans of tomato sauce for making pizza. Each can contains 2 gallons of sauce. Is there more or less than 50 liters of sauce in these 8 cans? So, first we're talking about gallons and liters, yes? So I go to the top and I find which conversion at the top talks about gallons and liters. And I see that 1 gallon is 3 79/100 liters. So that is where I am starting. That's what you start with. My 1 refers to gallons. So I need to put gallons at the top of the next fraction and use that to find the bottom answer. How many liters? So how many gallons are in these 8 cans of sauce? Each can contains 2 gallons, so if you have 8 of them, there is 16 gallons. So what am I going to do to 1 to get to 16? So I need to multiply 3 79/100 times 16. It's the same exact thing we did with ratios and percents, guys. The exact same thing. 6 times 9? 6 times 7?
42.
Plus 5?
47.
6 times 3? Plus 4?
18 plus 22.
Cross that out. 1 times everything is itself, so a placeholder. And then I can add them together. So 7 plus 9 is? 1 plus 2? 3 plus 7? 1 plus 2? 3 plus 3. There are 2 numbers behind the decimals in my problem, so there should be 2 numbers behind the decimal in my answer. So I get 60 64/100 liters. So my question was, is there more or less than 50 liters of sauce in these 8 cans? So what should my answer be? More. Start it the same way every time. All right, so you have about 2 minutes, 3 minutes to work on the next problem. It says, Tyrone, the quarterback of the Tigers football team, can throw a football 40 meters. Jason, the quarterback for the Spartans, can throw a football 45 yards. Who can throw farther? And how do you know? So let's start with what 2 units are we talking about in our problem? Meters and yards. So if I look up here, I see that 1 meter is 1 900 yards. And I just write that as a fraction. Now I know that I want to multiply times the 1 because it's easy. Anything times 1 is easy, right? So 1 represents our meters. So I'm going to look for meters in our problem. Whose distance is in meters? So this is Tyrone. And we're going to change Tyrone's to yards. How many meters can he throw? 40. So what do I do to 1 to get to 40 meters? Times 40. So 1 900 times 40. Let's figure that out. Everything times 0 is? So I can just put a 0 as a placeholder. 4 times 9? Carry my 3. 4 times 0? 0 plus 3? And 4 times 1? There are 2 numbers after my decimal in my problem, so I should have 2 decimals in my answer. So I get 43 60/100 yards. So if Tyrone can throw 43 60/100 yards, and Jason throws 45 yards, who throws the farthest? Jason. Jason throws the farthest. Any questions about how we did that one and how we decided what went where? All right, let's look at the next page. This one is very similar. It says Molly says that she is 1.5 meters or 1 5/10 meters tall. Shauna is 5 feet tall. Molly says she is taller, but Shauna disagrees. Who is correct? And explain your reasoning. So you're going to work it out the exact same way and use your conversions from the page before and decide who is correct and who is not, and then we will come back in about 5 minutes and discuss. Go for it. Okay, so what 2 units are we talking about in our problem? Meters and feet. So what do I know about meters and feet from our conversion chart on the page before? 1 meter is 3.28 feet. Is that right? Okay, and since my 1 is represented in meters, I am looking for my meters in the problem, and that is Molly. Molly is measured in meters, yes? And how many meters is Molly? 1.5 or 1 5/10. Thank you. So how would I go from 1 meter to 1 5/10 meters?
1.5.
Nate, what do I do?
You multiply by 1.5.
You multiply by 1 5/10. So if I do that to the top, I need to do the same thing to the bottom. Please stop tapping. Thank you. 5 times 8?
40.
5 times 2?
2, 10,
10 plus 4?
14,
5 times 3?
15,
Plus 1?
16.
Put my placeholder. 1 times everything is itself. 0 plus 0? 4 plus 8? 1 plus 6?
8, 7,
7 plus 2?
9,
And 1 plus 3.
4.
So I get 49 and 20 hundredths. All right, so if I just converted Molly into feet, I can now compare her with Shauna's feet. Yeah, I did something wrong. Hold on. Thank you. 4 and 92 hundredths. My bad. I just don't like talking over people, so y'all are frazzling my brain today. So, if I'm comparing Shauna's 5 feet to Molly's 4 and 92 hundredths feet, who is taller? Shauna is taller. Does everybody agree? Good. I'm giving you about 10 minutes to work on 7 and 8. Go for it. Nope. 10 minutes, 7 and 8.
Okay, on all of these. So here we have Larry, he weighs 110 pounds, Casey weighs 98 pounds, Sean weighs 42 kilos, and Jamal weighs 52 kilos. Place the boys in order from least weight to greatest weight. So there's our task. Meaning I need to convert. So in order to compare something, they need to be the same. So I can either convert the pounds to kilos or the kilos to pounds. Given the conversion factors they've given us, it's going to be easier to go from pounds to kilos. Because if I go to the previous page, it says 1 pound is 45 hundredths of a kilo, correct? Couple of notes. First off, I always want what I'm converting from to be a 1 right here. That's what's going to make this easy. So that should help you decide which one I want to convert. So I always want the 1 there because the other piece I know is going to go here. So if I know that I'm going to 110, 1 times what is 110? 110. Meaning I'm going to do 45 hundredths times 110. So 45 hundredths times 110, I've got 2 decimal places, gives me 0, 45, 0, 0, 45, 0, 5, 9, 4. I put 2 decimal places in, So that's 49.5 kilograms. So we now have Larry's weight. Then we also need to do Casey because he was the other one that was in pounds. Our first conversion factor is exactly the same. All that's going to change is what his weight is. So he's now 98 pounds. So now I'm going times 98. So 4,500 times 98. 4,500 times 98 gives me 2 decimals. Now I'm just doing 45 times 98. Gives me 40, 32, 36. 45, 36, 40. And I put them together. 0, 11, 4, 4. I need 2 decimal places. So that's 44 and 1/10 kilograms. Please, guys, this is the most important part of everything. If you have it set up properly, all the rest should be easy. And it starts with, what am I converting from? That's the question you need to ask yourself. If you know what I'm converting from, I want the 1 of that unit in this top spot. Now that I've got them all converted, I can actually answer our question, which is putting them in order from least to greatest. So what number was the least? Okay, so the order is Sean, because 42 was the smallest. Then who? Then Casey. And then Larry. And our last was Jamal. Does that make sense to everybody now that you're seeing it? You understand the importance of setting up your proportion correctly? Because that's honestly what it's all about. Karen has a gold bracelet, weighs 24 grams. She wants to sell the bracelet, but needs a minimum of 1 ounce of gold to sell it. Can she sell her bracelet? This is the easiest one in the world, because they told us what? 1 ounce is how many grams? What's our conversion factor?
0.035.
Look at the other page. 28.335? 35. 1 ounce is 28 and 3,500 grams. She needs 1 ounce. She only has 24 grams. Did she make it? No. No, she needs another 4.35 grams to sell. That one, literally all you had to do is set up the conversion factor and compare it to what they asked you. Questions on anything on these pages so far? Okay, so let's take a look. Go to page 311. Now we can use different methods to convert units of measure. You can set up a proportion and scale up or down to convert 1 unit. You can also use a method called unit analysis. To use this method, instead of an equal, we're going to multiply the given measurement by a form of 1 to rewrite it with different units. Okay? Let's go ahead and pull out our highlighters real quick. Yeah, if you still have them out, that's better. So, units carry through all calculations. Units divide out in the same way that factors divide out. So if I'm doing a unit analysis method, I'm going to say the given unit goes on top and bottom. My desired unit is what gets left on top. So you can see the biggest difference between what we've been doing and what we're doing now is where the units are located. So if I am scaling up and I want 1 kilogram is about 2 2/10 pounds, to figure out how much is in 4.5 kilograms, I've got 2 methods. We've got this way, which we'll be honest, this is the way Ms. McShannon and I really want you to do it. Okay? Why? Because it's going to be easier. In this method, I want to start with what I'm converting. So I'm converting kilograms, so that's going to go on top. And I write my conversion factor with the 1 kilogram on top, so I know exactly what to do. Okay? Because in this case, I now know I'm multiplying by 4 5/10, so I'm multiplying by 4 5/10. The unit analysis method, the big difference is where things are located. Here you notice I have kilograms on top for both of them, correct? It's because I'm going from one to the other. In the multiplying method, number one, my equal sign is now gone. It's not equals now. Now in this case, I'm actually multiplying. Because I am multiplying, my units are on opposite sides because they're canceling out. The idea is get rid of the unit that I don't need. Okay? And that's going to tell me whether I'm going to divide or multiply. In this case, the bigger number's on top, so I'm going to multiply. In both cases, you're going to get the same answer. Now, historically, this is the way I prefer to teach it, but I'm actually, because we've got focused so much on proportions this year, this is going to be your easier way to do it, guys. So while we have this available to you and you can use it, this is what we would like you to get more comfortable with. So we're going to do some more work. Both strategies used a form of 1 to determine equivalent number of pounds and 4.5 kilos. How is form 1 of scaling up different? It's where the units are located. And here's what we want you to remember. Both on top for the proportion. And the other big difference, proportion uses the equal sign, where unit analysis uses multiplication. That is the biggest differences between those two methods. But they are huge differences because the math goes completely different. Is everybody okay so far? Okay. So why do you cross out the labels for kilograms in the unit analysis? And this gets back to a simple understanding. So I'm actually going to go through a little analysis to help you understand this. Okay, what if I have 3 over 3? What does that equal? 1. What if I have 25 over 25? What does that equal? 1. What if I have kilograms over kilograms? What does that equal? 1. If I have the same thing divided by the same thing, it's always 1. So basically what we're doing in the unit analysis method is we're getting rid of the units. We're crossing them out and calling them ones. They're crossing each other out. Okay? So that's why we do it. Is everybody okay so far? So let's get to some more practice. Give you some more time to be able to understand what we're doing. So here we've got a marathon, a long distance race, official distance of 42 and 195 kilometers, or 26 miles and 385 yards. They both want to determine the number of miles in 5 kilometers using unit analysis. Do we want them to use unit analysis, or do we want them to use proportions? So set up proportions to understand who is correct. Okay?
We've been doing it, guys.
The way we've been doing it. So you're going to do 1 kilometer. Yeah, you're not going to use those two. You're going to use this rate, but we're switching to 5 kilometers. So I want the kilometers on top.
I know, like, do we have another conversion somewhere?
Do we have a kilometer version? 2 pages back? Should have. 3 pages back. So here is your mile, a kilometer. They didn't do it. So we'll use this one. 1 meter is 30, multiplied by 2. No, that's in feet. That's not going to work. Don't have it.
That's not a good problem.
That's not a good problem, given what they've given us. So what's at the bottom? Right, but we need kilometers to miles. because they gave us 5 kilometers. We need to switch on the kilometer side to figure out the miles. So wish they had it in there. 1 mile. Okay. Okay, so 1.61, 1 divided by 1 and 61 hundredths, .0, no. So guys, the conversion factor we want you to use, 1 kilometer is about 0.62 miles. So use this to determine which one of those is correct, if it comes out to 8 and 5 hundredths or 3 and 11 hundredths. So here's your conversion factor. 1 kilometer is about 62 hundredths of a mile. And then you can use that same one to work out all of table 4. If they give you the miles, you'll have to use this one. No.
Can we just not?
We could.
Let's just not. Let's not. Because let's just not. Let's not.
The problem is trying to avoid the other way they're trying to teach them.
I don't like it.
Okay?
Either.
We have 5 minutes.
I know we have 5 minutes.
So we shouldn't do it.
So we'll skip that page.
Yeah.
This one you should be able to do though.
Oh.
So we're on 312.
5. Nobody said for you to open your mouths. Hush.
Is this 313? Here's where you got off. So here's 313.
You know, Friday was a rough day.
So we have $1 for every 3 and 1700 Brazilian dollar reals. So good. You'll have to figure these out. You're doing all of number 5. You got 4 parts to that. And then you should be able to do number 6 as well. So actually, we'll just work on number 5 for now. We'll give you 3 minutes. Go. Guys, it's time to have go over, in order to have time to go over the homework, let's go straight to that. So page 315. Please be quiet and take note. I'm about to help you with what you need to do on your homework. Okay, on this one is use any strategy, use the proportion, like we've been trying to teach you. So they gave you an equivalency. Dollar is equal to 7 pulas. Make sure you try to figure out how she can do each of these. Then she goes to dinner. She's got all those there. How many feet are in 4 yards? Remember your conversion on that is 1 yard is 3 feet. On this one, how many gallons are in 14 quarts? This one, 1 gallon is 4 quarts. So I just gave you the initial setup for both of those. On this one, we're switching from kilograms to grams. So that one is going to be 1 kilogram is 1,000 grams. Okay? Yes, ma'am.
Should number 3 be 1 quart is 1/4 gallon?
Which way is it going? 14 quarts? Yeah, it should be. So 1 quart is 0.25. 1 gallon, or 1 quart, sorry, for switching from quarts, is 0.25 gallons. And then this one is switching from meters. So 1 meters to kilometers is 0.001 kilometers. Then on the last page, now we're switching around. They've got pounds to kilograms. Then we've got kilometers to miles. And we've got inches to centimeters. So you have to go back to the conversion factors 4 pages ago. And this one, he commutes a long distance. He's comparing their capacities because he wants the fuel tank to be as large as possible. Okay? So pick the largest capacity. Pick largest fuel tank. So that's kind of like the ones we did earlier where you're going to have to convert them all to the same units. So you have gallons, liters, and quarts. Pick which one you want, but switch them all to the same. So make them all gallons, all liters, or all quarts. Good luck, guys.